Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
We'll see parsing, different parsing methods. Mainly two techniques, top down and bottom up. In top down, backtracking, you can say with backtracking or simply backtracking. And without backtracking. We can call this as predictive parsing. And again in this, recursive descent, parsing and non-recursive descent parsing. Or we can call this as L of 1 parsing. LL of 1 parsing. And coming to this one, bottom up, here shift reduce parsing and operator precedence parsing and LR of K parsing. LR of K. Shift reduce parsing, operator precedence parsing and LR of K. In LR of K, again LR of 0 parsing and SLR of 1 parsing and LALR of 1 parsing, finally CLR of 1 parsing. So mainly two divisions, top down and bottom up. In top down, backtracking and without backtracking. In this, recursive descent and non-recursive descent. Shift reduce, operator precedence, LR of K. In LR of K, LR of 0, SLR of 1, LALR of 1 and CLR of 1. Okay, we'll go to next. So, what is top down and bottom up? We'll see. Okay, for this I am taking one example of grammar. Let this is the example for S derives AB and A derives AA or A and B derives BB or B. Let this is the grammar I am taking example. What is top down? It is from root to leaves. This means it starts from the start symbol and derive the string. What is the start symbol in this grammar? Let S is the start symbol and S, A, B are the non-terminals and small a and b are the terminals. Okay. For this, from this grammar, I am deriving this one string manually, which starts from S. Okay. And S derives AB I am taking, and in A place we can go for AA or A. I am taking AA, and in A place again we can take AA or A. I am taking A, and in B place we can go for BB or B. I am taking B. So we derived AAB. AAB can be derived from this string. Okay. What is the top down? It starts from the root, means start symbol, and it derives the string. Okay. Next one. Uses leftmost derivation. Uses leftmost derivation. This means every time it apply a production, LMD means it every time it apply a production to the leftmost non-terminal. Okay, what is this? It starts from the start symbol S, and S is the only one non-terminal. Here we can apply a production to either S. Okay, sorry, I repeat. Here S is the start symbol, and here only one symbol S. This S we can consider the leftmost symbol as well as rightmost symbol, because there is only one production. So this time I am considering this as leftmost symbol. Okay, I am applying a production to S. What is the S production here? AB. Now after this step we can apply to A. In place of A we can go for AA or A, or in place of B we can go for BB or B. But in these two, which one is the leftmost symbol? A is the leftmost non-terminal. Leftmost non-terminal. So what is LMD? If we apply a production every time to the leftmost non-terminal, that is called LMD, leftmost derivation. So in A place we can apply A or AA. I am going for AA. Again, here two non-terminals. In these, which one is the leftmost? A is the leftmost. In A place, again we can go for AA or A. This time I am going for A. Now which one is the leftmost? B is the leftmost because that is the only one. And in B place, we can go for BB or B. This time I am going for B. So it takes the root, the start symbol, and it derives the string. So from root to leaves, and every time it uses LMD, means the production will be applied to the leftmost non-terminal, and uses, actually we take a symbol and we derive the string. Taking symbol, we derive the string. So uses derivation process, we derive the string here. This is top down parsing. Okay, what is bottom up? It is from leaves to root, means it takes the string, and that string will be reduced to start symbol. So same example I will explain here. So if you want, you copy this one, I delete. Next. Okay, what is bottom up? It takes the string and reduce that string to start symbol. Okay, from this grammar we can derive the string AAB. We have seen this derivation. Now we take this string and we reduce this string to start symbol. In this A place, A will be reduced with left side of the production. What is that? The left side of the production, A. Next, AA, this AA will be reduced with left side of the production. B, this B will be reduced with left side of the production. That is B. Next, this AB will be reduced with left side of the production. So we take the string and that string will be reduced to start symbol. This is called leaves to root, the bottom up parsing. Okay. So this reduction from string to start symbol, if we consider in the reverse direction, so actually we take the string and this string will be reduced to start symbol. So I explain this string in the reverse order, means here S2, this one, S is leftmost symbol or rightmost symbol, because this is the only one symbol we can consider this as leftmost symbol as well as rightmost symbol. I am considering this as rightmost symbol this time. Okay, so we apply this production to this non-terminal S. What is the S production? AB. Okay, S plus AB. Now after this step, we can apply a production to A or B, but in this, which one is the rightmost symbol? The rightmost symbol is B. We apply a production to rightmost, it's B. Now in this only one, so this time I am considering rightmost, it's production AA and its production A. So it takes the string and that string will be reduced to start symbol. In this whole reduction, if you consider in the reverse order, it will be using the rightmost derivation. So this bottom up parsing uses rightmost derivation in reverse order, means this string start symbol to string, it will be rightmost derivation. And actually we take the string and that string will be reduced to one symbol. So it uses reduction process. This is about top down and bottom up. Now we'll go for each technique individually. What is bottom up and what is backtracking, without backtracking, and shift reduce, all of them. With backtracking or simply backtracking. In backtracking process, there are no rules and regulations. A grammar will be given and a string need to derive. So the parser will start from the start symbol and it tries the different productions. Actually, there will be no rules. Whatever the given productions, by taking those productions, it tries with different productions until it get the required string. So I repeat, backtracking is a process of trying different productions until it get the required string. Okay, in these trials there will be no rules. So whatever the available productions, it will try them randomly. Okay, so example, I'll take the small grammar as derives AB. So whatever we have seen earlier, the same grammar here also I'm taking. A derives AA or A, B derives BB or B. Let this is a grammar. Okay, from this grammar we can derive the string AAB. Already we have seen this is the valid string. Now what is backtracking? It starts from the start symbol. It is a top down parsing. Okay, means it starts from the start symbol. So what is the string to be derived? AAB. What is the first symbol it required? A. So S has only one production, AB. Okay. Now in A place it has two productions, AA and A. If the parser goes to A, in A place it can apply to this, it can go for this or it can go for this. In A place if it goes to A. Now in B place either it goes to BB or it goes to B. The string, so here A derived already because the string already we got A. Next the pointer comes to this position and the second symbol required is A, and but here in B, so what is the string here? A and this is B. So actually it required the second symbol A. Now it's B. In B place, whether we go for B production or BB, the second symbol A will not be derived. So the parser will go for backtracking. Now S derives AB, If the parser goes to AA, yes, it has to go for. Now it got A, okay. Next A. So again, if it goes again to A, it may go for A also. I am just verifying. The parser may go for these many trials. Okay. Now here it is A and here. So this is derived, first symbol derived and second symbol derived, it goes to B and now A. In A place, either you go for A or AA. So that third symbol will not be derived. So again it go for backtracking. Yes, there is AB. Now the parser will go for AA and it goes for A. Then it got this A, and if it go for BB, the parcel may go for BB, and again no, it is getting the string more than derived, so more than required. So as there is AB and A there is AA, and this is A and this is B. So finally it got A, B. Okay. See, actually I don't say that the parser will do like this only. As there are no rules, the parser may perform, it may go for the trials like this. See, this is very small grammar. Here only the 5 productions. Even the string is also very small. The length of the string is 3. For this small string, from this small grammar, the parser may go for these many trials. Just imagine if the grammar is having thousands of productions, if the productions are in thousands, and if the string is too large, let the string length is 20 or 30. When there are thousands of productions, when the string is too big, when there are no rules, then how many trials the parser may perform like this? So the parser definitely should go for several trials. So because of those several trials, it takes more time to derive the required string. So that's the reason we say backtracking is a slower process. Why it's slower? Because if the grammar is having the many productions and if the string is too large, when there are no rules, the parser blindly has to perform several different trials. So because of those different trials, it required more time. So that's the reason we don't prefer backtracking. Okay, copy. Next, LL of one parsing. What is this L? The first L stands for the string will be read from left to right. So L stands for left to right scanning of the input string. Next one. Uses leftmost derivation because it is the one of the technique in top down. The top down uses leftmost derivation. I told you, okay? And this is the look ahead symbol of length one. Look ahead symbol of means every time it scans the string of input symbol of length one. It scans the string. Suppose this is a string. It scans every time one symbol at a time. That's the meaning of look ahead symbol of length one. Copy. Okay. Actually, in a grammar is given, they ask you, is that grammar is LL of 1? Means, is the grammar is LL of 1 grammar? To know whether a given grammar is LL of 1 or not, LL of 1 or not means, can we parse that grammar? Can we parse the string from that grammar using LL of 1? Okay, so we cannot use every method for every grammar. A given grammar may not be suitable for LL1 parsing technique. So how to decide whether it is possible to parse the using LL1 or not? So depends on the procedure. We construct some table, and based on the procedure we fill these boxes. So after completion of this filling, wherever in every these box we fill the productions, means we write the productions here. Suppose any box having multiple productions, example here, and suppose this, and this box is having multiple productions in, then that grammar is not LL1. Even though you don't fill the boxes, no problem. Wherever you made the entry, and any box, if it contains, the same box contains multiple entries, it is not LL1. That means we cannot use the LL1 parsing technique on that grammar. That's the meaning. So how to decide a grammar is LL1 or not? So I'll tell you with small example, then we go to the a standard question now. Suppose this is the grammar. Is this grammar LL1 or not? Okay. What are the non-terminals in this grammar? S, A, B. Whatever the left side of the arrow, they are non-terminals. S, A, because only one non-terminal will be there in every portion, because we are dealing with context-free grammar. In context-free grammar, there will be only one symbol on the left side of the arrow, that too non-terminal. So Here SAB are the non-terminals and the rest of the symbols are the terminals. What are the terminals here? Small a and small b. Okay. We construct the table. The table structure will be like this. In the columns, we take all the terminals. In the columns, we take all the terminals. What are the terminals here? A, B. And we don't take the epsilon in the columns. So take all the terminals excluding epsilon, including dollar. We don't take the epsilon, we take the dollar. Okay. And these columns, these terminals are in columns and the rows will be the non-terminals. What are the non-terminals? S, A, B. So in the rows we take the non-terminals, we fill this okay. This is the structure of the table. So all the non-terminals in the rows, all the terminals in the column, excluding epsilon, including dollar. Now, how to fill this table? Okay. Any production from this grammar will be of the form A derives alpha because it is a context-free grammar. Okay. Suppose this is the production. How to fill this production in this table? We write, take the procedure. We consider every production of the form A derives alpha because this is a context-free grammar. I repeat, every time, every production, the left side will be single non-terminal. So we take every production of the form A derives alpha and proceed as follows. How to, what is that? The first one, the procedure, first one. We write A derives alpha in the box of, this is the A's production. The left side of the arrow is A. It is a non-terminal A. So we write this production in the eighth row because it's the eighth production. If it is B derives alpha, we write in the bth row. So write this A derives alpha in the eighth row and xth column, where x is first of this part, first of alpha. I repeat, we write A derives alpha in the box of 8th row and xth column, where x is first of alpha. Okay, so based on this, I make the entry. Now take the S derives AB. This is the production of S. So we must write this production in the box of S row because it is a S production and xth column. What is x here? X is first of alpha. What is alpha here? AB. First of AB. First of AB is what? First of A. What is first of A? To get the first of A, we must take every production of A. A has two productions. So this one and this one. What is this first here? A. What is first here? B. So first of A is A comma B. I repeat, we take this production and we fill this production in the S row and xth column, where x is first of AB and first of AB is first of A and first of A is A comma B. So in S comma A and in S comma B, we write this production. So S comma A, this one. and S comma B, this one, we write these places as there is AB. Why in S row? Because it's the S production. Why in the 8th column and Bth column? Because X is first of alpha. First of alpha is first of AB. First of AB is A. First of A, and it is AB. So this production is completed. So like this, we must take every production in the grammar, and for that every production we make the entry. Next, we take A derives AA, this one. So we must write this production in the box of Ath row because it is a production of A, and Xth column. What is X here? X is first of A, this one, first of alpha. Alpha is AA. And what is first of AA? This is A. So we write this production in the 8th row and 8th column. So here 8th row, 8th column, write this production. Okay. So this is A's production, that is the reason 8th row. And alpha is AA. First of alpha is first of AA, that is A. So A comma A, we write this. Next one. So this is also completed. Now take the next production. A derives B. This is a portion of A. So write this production in the 8th row and Xth column. What is X here? First of alpha. What is first alpha here? B. So first of B. What is first of B? Is B. First of any terminal is the same. So first of B is B. So we write this production in the 8th row and X, which is B. So 8th row, Bth column. We write this production. Done. Next, we'll go to next production, which is B derives BB. Okay, this is the production of B. Therefore, we must write this production in the Bth row. Because this is the production of B, we must write in the Bth row and Xth column. What is X? X is first of alpha. What is first of alpha here? First of BB. What is first of BB? Same B. First of BB is, which is B. So we must write this production in the Bth row, Xth column, which is B. So Bth row, Bth column. Here, what? This production. Whatever the production we are taking, that production. So Bth row, Bth column, we write. Next. So this is also completed. The last production, B derives epsilon. Again, this is the production of B. So we must write in the Bth row and Xth column. What is X? First of alpha. What is first of alpha? Here alpha is what? Epsilon. First of alpha is first of epsilon. First of epsilon is epsilon. So we must write this production in the Bth row and epsilon column. Okay, Bth row, epsilon column. Where is epsilon? There is no epsilon in the columns. Bth row is there, but no epsilon column. So if this is X is first of alpha. If first of alpha is epsilon, then there is one more rule. The second point. Actually, we must write A derives alpha in the 8th row and Xth column where X is first of this alpha. Okay, now the second point. If first of alpha is epsilon, then write A derives alpha, write A derives alpha in the box of 8th row because it is a production of A. 8th row and yth column. If first of alpha is epsilon, this is epsilon, write this production in 8th row, yth column, where y is this one, that is follow of A. Where y is follow of A. Okay, now the last production, B derives epsilon. Here first of epsilon is epsilon, therefore we must write this in the box of bth row, yth column, where y is follow of B. So to find the follow of B, we must find the productions wherever B is on the right side of the arrow. Here B is on the right side of the arrow in two productions. One is this one and the other one is this one. I repeat guys, to find the follow of any non-terminal, we must find that non-terminal wherever present on the right side of the arrow. Here B on the right side in this production and this production. So on the right side of B, nothing. Then follow of B equal to follow of B equal to follow of B. With this we cannot find anything. Just leave this. And here on the right side of B, nothing. Then follow of B equal to follow of S. So follow of B equal to follow of S. And to find the follow of S, you must find the production wherever S is on the right side of the arrow. S on the right side of the arrow, nowhere available. But S is the start symbol. Follow of every start symbol is $. And follow of every start symbol is not only $, it may contain more symbols if S, that start symbol is S is if available on the right side of the arrow. Here S is nowhere on the right side. Therefore, follow of S is only $. So follow of S is $, and follow of B equal to follow of S, which is $. So finally, follow B is $. Okay, I repeat guys. B derives epsilon. As this is epsilon, we must write this production in the bth row and yth column where y is follow B. What is that? $. So we write this production in the bth row and column. Bth row and column. Here we write B derives epsilon. So we have completed every production. This one, every production you must take, and we take that and we fill that production in this table according to these rules. And finally here some boxes are unfilled. So these unfilled entries, we call them as syntactical errors. This is error and this is also error. So these unfilled box, don't bother about this unfilled entries. So wherever we have filled, here and here and here, this and this and this. So in all these spaces, if we made only with one entry, then we call that grammar as LL(1) grammar. I repeat, wherever we have fill, if all those are single, then the grammar is LL(1). Yes, in this table, all the entries are single. This is single. So this grammar is LL(1). Means we can parse using LL(1) parsing techniques this grammar. So the grammar is LL(1). I repeat, if all the entries in the table are single, then the grammar is said to be LL(1). Yes, of course, it is LL(1). Copy. Actually, this is the procedure to decide whether a grammar is LL(1) or not. Means we take all the non-terminals in the rows and terminals in the columns excluding epsilon, including dollar, and after filling, if every entry is single, then it is LL1. And we can decide whether a grammar is LL1 or not within seconds without going to this procedure. Actually, this is useful. This procedure will be useful in your semester exams. But if you go for GATE examination, within seconds, by looking at this grammar, we can say less than 1 minute, maybe within half minute we can say whether it is LL1 or not. No need to construct this table. So how is that? We will see in the next session.